Okay, I'm gonna do some more testing. I hooked up all the caps together in parallel, so this is equal to 5,600 UF. And I just did a video with a drawing of how the steering diode is switched into the cap bank. And so now I have kind of the steering diode goes straight. This is if I want to disconnect it. Goes straight into the cap. Okay. And then on the other side, this side of the diode, and here's the drain of the MOSFET's this wire. See that, the red wire, that goes right into the MOSFET. So this is essentially the drain, also the output of the motor coil, because you send in the positive DC into the motor coil first, and then out, and then you go into the MOSFET. So that's what this is. This goes to the MOSFET, and I have a connection here. And this goes into the switcher. It's a bi-directional MOSFETs. Two of them, source leads connect, gate leads connect. The switching occurs between drain A and drain B. And so here's the into that switcher. Here's the out. And the out goes to here. So this is what I show when I say that I move the switch. It used to be this switch was between the steering diode and the cap, but now it's not. It's between the drain and the steering diode. So between the drain of the MOSFET, which is also the output of the coil, I switch into the steering diode. Okay, so whatever, you can go back and look at that. So all this is concerned about is having this delay of the back EMF, a little bit, about 5 degrees delay time before you hook it up. And you go back, I think, about 3 videos, and I made a little drawing explaining that. So that's what this is about. There's no load here. The load, you could say, is the filling these big cap bank, but the real load is over here, is the 17.5 ohm coil, and that gets switched in 4 times a revolution. As I explained earlier too, I popped out every 4th magnet here, and during that blank space, when there is no motor coil pulse too, that's when I use this switch to dump this cap bank into the load. And so that's the output, that's the power. Okay, you don't have any power until you hit a resistive load, so that's what this is. And so I have a total of 3 switches. I have the motor coil switch, little right here. The drain of that is what kicks out the flyback back EMF through this steering diode. And now I don't just put it right into the caps, I delay it a little bit with this switch. And so now the cap's filling up, and then 4 times a revolution I switch it in with this switch. So I have 3 switches. I have the motor coil switch, I have the delays, the flyback delay switch, let's call it, and then the final dump the cap to the load switch over here. Okay, so let's look at the, just make sure everybody knows. Luke wrote a comment and he wasn't sure what was going on, so I want to make sure everybody knows what's going on. There's 3 Hall effects here. 3 Hall effects. There's one here. This is the motor coil. It pulses the motor coils. On the back side, right next to it, just a little bit downstream, is another one. And that's about, like, I don't know, 1.5 millimeters off is the second one. And that's the delayed, where you connect the flyback a little bit delayed. The one on the top, Hall effect on the top, is what goes in 4 times a revolution, what has the cap go into the load 4 times a revolution. And okay, so I've been through this a lot. What's going on? The change I made is how I switch this in. Okay, now here we go. I checked the RPMs. It's 515 now, which is pretty fast for this, and it's only drawing 10 milliamps. This meter, you have to touch it to. It's drawing 10 milliamps and 6 volts, and off this 9-volt battery. Now, when I hook up this battery over here, the caps will start to fill. I want to get my ammeter ready, actually. Hold on a sec. I'm going to pause for a sec. Okay, I'm back. I got it working now. And it's right now we're filling up the cap. It's up to 12 volts. It's this battery's connected, so this switch is sending in the flyback back EMF into the cap bank, about 5 degrees delayed to the motor coil pulse. Okay, we're up to 15 volts, and I just hooked up the ammeter to measure current going into the load, right next to the load where it gives the high amps, because that's what I want to see. So when I hook this up, you hear it? It's pulsing. There's the amperage going in to this coil. Now, here's the voltage, 5.7. And here's the amperage again going in. And here's this again. Now the draw has not gone up too bad. Still 10 to 20, so I'd say it's about 15 milliamps. And it's still going at a good rate of RPMs. I think it's dropped to about 400. Let's see what it says. 412. 412. Okay, when it was without pulsing into the load and everything and collecting into the cap, it was going 515. So it's gone down about 100 RPMs. But that's really good, because if you saw some earlier videos, if you just take this and throw it right into the cap with none of this delayed switch going on, it just lugs down to practically nothing, wants to stall. But now it's going at a good rate. So I guess that's about it for now. Okay, thanks for watching.